What is the biological inspiration for activation functions? Imagine your brain's neurons firing off signals to help you think, move, or feel. That process is the real-life inspiration behind how artificial neurons work in deep learning. When a biological neuron receives signals from other neurons, it sums up these inputs. If the total exceeds a certain threshold, the neuron fires an action potential, or fires. This firing is not just on or off but depends on how strong the input signals are and the neuron's internal state. In biological systems, neurons show a thresholding behavior. They stay inactive until the input reaches a specific level. Once that happens, they produce an output signal, which can be thought of as a firing rate. Early artificial activation functions, like the sigmoid, mimic this by smoothly transitioning from low to high output as input increases. This smooth change resembles how neurons gradually increase their firing rate as input signals grow stronger. More recent activation functions like the rectified linear unit, or ReLU, simplify this idea. ReLU outputs 0 for any negative input, mimicking the firing threshold of neurons. When the input is positive, it responds linearly, just like a neuron firing more strongly as input increases. This simple model makes calculations faster and helps neural networks learn more efficiently. Biological neurons also adapt over time. If a stimulus stays constant, neurons tend to reduce their response. This adaptation helps the brain focus on new or changing information. In artificial neural networks, some activation functions and models incorporate this idea of adaptation. It helps the network learn better and stay stable over time. All these features, thresholding, graded responses, and adaptation, are the core biological ideas behind activation functions. They allow artificial neural networks to process complex data, recognize patterns, and make decisions. Understanding this biological link helps us see why certain activation functions are chosen and how they influence the behavior of AI systems like ChatGPT, DALL-E, and Midjourney. Knowing the biological roots also helps us think about the ethical side of AI. Activation functions impact how models generalize, how predictable they are, and how fair their decisions can be. This connection to biology reminds us that AI systems are inspired by living brains, which adds a layer of responsibility to how we develop and use these technologies.